Okay, we are trying to find the antilogarithm using logarithm table. Our logarithm table can as well be used to find the antilogarithm of a number. For example, now we are given these three questions here. Find the antilogarithm of 0.7597, antilog of 2.5463, and the antilogarithm of negative 2.0258. So we are going to look at each of these questions and we are going to do it. So when we are asked to find the antilogarithm, this is our solution of number 1. Antilogarithm, it means the question is like this: logarithm of a certain number equal to this 0.7597. This is what it means. Okay, this is what reflects here, right? So if that is the case, then it means that we are finding the number whose logarithm is this one here. We are finding the number whose logarithm is 0.7597. Okay, so we go back to our logarithm table and see how we can get this number here. So this is our logarithm table. As you see here, it is a logarithm table, and we use this logarithm table to find the antilogarithm. So when we use logarithm table to find the antilogarithm, it means that we are going to look from inside towards outside. We're not going to look from outside toward inside. No, we look from inside towards outside. Our number is 7597. So we are going to look this mantissa from inside of the logarithm table and see what number outside corresponds to it. So we look that we look 7597, 7597, 7597. You look inside. So you see here we have up to 4. You go down to find this 75. Yeah, it is something 7597, 7597, 7597. Very close now. 7597 here. So we have it here. 7597 exactly. 7597. So you move outside in this row, you find that you have 57. Okay, so you write somewhere here 57. Okay, this will be equal to 57. So antilog 75 97 equal to 57. Not yet done. Okay, equal to 57. Under this column here, it is under 5. So it is 57, then under 5. So we finish by writing this 5 here where we found it. So it is under 5. So we obtained this on 57 under 5. So we finish by writing 5 here. There is another 5 here. Okay, but now this is our characteristic. Okay, and mind you, to get this logarithm, the number was written in standard form. So we are going to write this in standard form. It is the same as 5.75 times 10 power this characteristic, which is 0. But we know that 10 power 0 is 1. So we say that antilog 5.75 times, the antilog of 0.7597 is the same as 5.75. This is the number which we are looking for, 5.75. That is the antilog of this logarithm here. Okay, now this we have to look. This is our b. We have to look for antilog of 2.5463. So as usual, we know that this is our characteristic. Okay, so it is our characteristic. So we leave it and we deal with the mantissa. Okay, so from this mantissa, go to your logarithm table. Right inside the logarithm table, as usual, the logarithm table is here. So you go inside the logarithm table and you look for 5463 inside the 5463. 5463 will be up. So 54 is here. 54 63 54 53 54 63 is between 54 53 and 54 65, so it is between here. All right, so we pick this one, which it seems to be much closer, so we are going to pick this one here. Mind you, that is not exact, so we have an extra of 2 points here, but we pick this. So we pick this and we read out. Outside we have 35 and we have the under. This is 0, 1, 2, so that it will be under 2. The under 0, 1, 2, so it is under 0, 1, 2, it is under 2, so it is 35, 2. 35. So this is equal to 35, 2. 2 is the same as 2, 0. Now mind you that as from here, you see this is a 5465, while we are looking for 5463. So there is an increment of 2, which we have to minus in our mean difference. So you look, the mean difference of 2, where will it coincide? 2, 0, 1, 2. 2 falls into, so that is 2, this is 1, 2, falls into 2. So we have this difference, mean difference of 2, which you have to take away. So you come here and you take away 2, you get 8153. So this is what you get. Now you change this into standard form, this number into standard form. This is the same as 3 standard form. This is the same as 3.518, then times integrals of the characteristic. Okay, the characteristic was 2, so it is times 10 power 2. So, and now we finish that. Antilog of 2.5463 is equal to, okay, this will be 35. We will travel 1, 2 to end here. 35, 1.8. This is the number. This is the number which gave this logarithm. And we can in fact read this from the logarithm. 35 under 1. Okay, different everything because we have 2 already. 35 under 1 gives you what? 35 under 1. Okay, 35 under 1 is here. It gives you 54, 53. Difference of 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. It gives you 10. When you add there, you get that logarithm and you find that it is really, really true. So that is how you can read the antilogarithm from. From the logarithm table. Okay, now we move for our last one, and which is challenging a bit. Last one is to find the antilog. Antilog of minus 2.0258. Okay? From the logarithm table, finding the antilog of this. Okay, now this is our last example here, which is to find the antilogarithm of -2. Now you see this is -2. -2, which means this number is below 0, because we know that logarithm logarithm of 1 equal to 0 and logarithm of 10 equal to 1 under base 10. So when we have a negative number, it means the logarithm of this number is below 0. It will be 0 point something. And when we are given in this case now, if we are given in this case, it means since the given number is negative, we have to make the mantissa to be positive. So because the logarithm table cannot read, it cannot give us any value of negative mantissa, so mantissa should be positive. So everything here is negative, so we have to make the mantissa positive and the characteristic to remain to be negative, which will be represented as bar. So if that is the case, then we have to do that. We have to make the mantissa. The mantissa should be positive, right? So we are going to see how we can do that. Okay. So therefore, we have to do some arrangement that -2.0258 is the same as -3. We go down one step. From -2 we are going to -3. So -3 plus 3 will give you 0. In fact, this thing here is equal to 0. So there is no difference because it is still -2.0258. So these things here are done to go to our point of bar. So this -3 here is the same as bar 3. Now plus you do the addition of 3. You now perform 3. You will perform 3.0000, then minus 2.0258 to make the mantissa positive, and this will give you 2. 9 minus 5 is 4. 9 minus 2 is 7, and we have 9 here. Then we have 0. It will give you this, but you have bar 3 behind because this is given by these two, this one to this one. So you have bar 3 behind here. So this is how we make the mantissa positive. Now we have made the mantissa positive. Now the process will go the same way we did other two examples. Mind you, when we were dealing with the first one and the second one, we went the same way. So here we are going to have this, that this is now what we have as bar 3.9742. So you will use your 4 figure to look at it, because this is your characteristic and this is the mantissa. Now you will use a 4 figure to read this, to find inside 97 under 3 and 97 under 4, 9742. 9742 from 4 figure table is here. 9742, it is outside, it is 94, and this is 94 is under, mind you, this is 0 1 2, it is under 2. So the answer will be from tables, it will be 94 under 2 0. We have a difference because it gave us 94, it gave us 9741. So we have a difference of 1. Difference of 1 is here, which is 0. So we don't have anything to add. That's why I added 0. And from there, what you have is, write this in standard form. It will be 9.42 times 10 raised to the characteristic. Integrals of 10 in the characteristic will give us this 10 times to the power -3, which is giving us 0.0092. So this is the required number to give the logarithm of -2. All right, so that is in fact the end, and I hope you understand. Thank you for following, and please try to go through once again many times to make sure that you understand what is intended. And if you don't, please subscribe, and you can call me, you can write through my email, which you will find it every time at this. So welcome anytime. Have a good day. Be blessed.